Boom. Okay, cool. Hi everyone, welcome again. Sorry about that. So it appears I didn't have audio, but now audio should work. Mm, please chat me up or send me a WhatsApp or send me a Discord if something doesn't work. But um, yeah, everything should be working now. So what we want to tackle today is that I have a different project that I'm working on, which is some signal processing. In my signal processing, I need to collect signals. I need to collect uh, some signals, some signals, and then once I have that signal with me, uh, if possible, a digital signal. But I can always get an analog signal, digitize it, and then go on from there. But if possible, if I can collect a digital signal and consume that, then I can do some signal processing on it, which is going to help me with some other with some assembly applications that I'm trying to build, I think. Okay, so that basically is the crux of my problem right now. And the sensor that I happened to choose was the LIS3DHSR on the STM32F4. I think I have a schematic somewhere here. So I have this schematic that shows this guy. This is a LIS3DSH. Let's just zoom in uncomfortably. So this is a LIS3DSH that's on STM32F4 discovery board. So this is the discovery board um, manual. Okay. And we have that peripheral. I think here's the peripheral. We have that these are the peripherals we have. But the LIS3D SHDR is it's I think a 3-axis or maybe a 9-axis uh, accelerometer. Let's see. It's a 9-axis or a 3-axis accelerometer. Yeah, it's a ultra low power, high performance 3-axis linear accelerometer belonging to the nano family with digital I2C or SPI interface. Okay, and it lives on this board. Cool. That's all normal stuff. So what is the problem? So as I've been the Zephyr has a driver which is called the LIS2DH driver. Let's go to the code, and then once we're in the code, we can once we're in the code, we can start digging around. So Zephyr has a driver, um, LIS2DH. Let's see. So there you go. This sample application periodically reads accelerometer data from the LIS2DH sensor or the compatible LS2DH12 or the LIS3DH and LSM303DLHC sensors. So ideally, it should be possible for me to just plug this in and run it. And let's attempt that, I think. So I am in that sample. Let's attempt that. So let's do west dash B dash P always let's build dash P always because we are developing stuff that changes all the time, and then dash B STM32F4 disco. Let's build that. There you go. So I'll build that, and then we'll try and run it on the machine and see what happens. And then once we're there, I've done a bit of this, but I want to include you from the beginning so that we can see. So basically, what we need to do is we need to run that um, driver and see, because we have a driver. We do have a driver. Yeah. git, git, Zephyr. So we do no, I don't want to do that. I want to go to Zephyr. Okay, cool, it's built. And then rest slash, and then let's choose a runner, open on CD. Okay, and because we have that runner, I'm running uh, almost a semi-hosting, but it's not really semi-hosting. It's a UART console into the device. That way, I can send messages to myself. Basically, we can see our first problem. If I reset the device, then you can. Uh, if I reset the device, you can see the problem. So you can see it boots. It it's booting, and then once it boots, it says invalid chip ID, LIS2DH. Yeah. Okay. So we are getting an invalid LIS2DH invalid chip ID. But remember this, in the code that we just looked at, it said the LIS3DH is LIS3DH. The LIS3DH version of this accelerometer is supported. Okay, but then it says, but then we see it going like there is no device with that ID. Okay, that's the first thing. So here, it says here that it found an ID, and the ID is 0 cross 3F. So first of all, let's go check this. So who am I? Who? Um, ah, okay, so it's reading that, and then device identification register. So we have 00110011. That's 3F, because 000110011. That sounds like 3F. But let's go and use let's do binary to hex. So we go binary. No, to decimal, to hexadecimal. So we want 0, 0, 0, 0, 1, 1, 0, 0, 1, 1. Okay, let's convert to 3. That is odd. Why would that be 33? 0, 0, 1, 1, 0, 0, 1, 1. That is odd. It should not be that. It should not be that. So let's do hexadecimal to binary, and then go 3F. Convert 0, 0, 1, 1, 1, 1, 1, 1. 0, 0, 1, 1. Do I have the wrong driver? The LIS3DH, so let's remove it. Excuse me. Sorry. Sorry if you're wearing headphones. Um, and then what happened to my iPhone? Sorry about that. Let's open that again. LIS3DH. So LIS3DH. Let's look at this one. Now I'm confused because that's 033. Uh, LIS3DHDR. What is on my what is on my let's look at what is on my drive. I'm trying to find out if I have the correct, if I'm looking at the correct list, LIS3DHDR. I'm trying to find out if I'm looking at indeed the correct diagram. LIS3DHDR. LIS3DHDHDR. Okay. Are these two different sensors? STM, STM32, LIS. Which one is that one? LIS3DH. No, I want to find out if this is actually STM32 3. Yeah, this is the same thing. No. This is not the same thing. DSH3R. These 3DSH. And I have on my machine LIS3DH. Okay. Fast mistake. Okay. LIS3DSHTR. So let's go here and check. Who am I? 0011. Yeah, there you go. Binary, binary to hexadecimal. 00. One, two, three, four. I should have done that. 3F. Okay. So number one, we found the thing. We found the thing. What I want to find out now, the difference. Okay, let's go here and do text diff check. Diff check. Are these two different sensors? Should they be the same sensor? So let me go here, here. No. first thing I want to just find out is, let's see this on this. Let me just copy that. And copy. Can I go into this check and put that as my source? And can I go here and just copy that? This check. I just want to check. Yeah, I want to remove this description. And then it should be completely different. So they're completely the same up here. They're completely the same as here. I want to now check the register maps. Add the register. So okay, cool. So what have we discovered? Number one is that the list, the list, the list 3DH and the list 3DH and the list 3DH might be different devices. That's not the first thing we've discovered. I just want to go to the feature list, to the can we look at I would like to look at what is called register maps. I would like to look at the register maps. First of all, we need to check if the register mapping is the same. And if it's the same, then it doesn't really matter what driver you use. If you're speaking to the same set of registers and they perform the same way, you're okay. You can use either driver, it will still work. Okay. But if the driver, the there could be a short circuit here into a solution in which I end up building a new driver for this new device, even though I thought it could be rolled into the other one. But let's look at the register mapping. I hope it's the same as the other one. Yeah, I want to go to the register map tree. It's three pages here as well. Let's compare each page at a time. Okay, cool. Something tells me these things are completely different. Okay, it looks to me like they're completely different ones, but let's just, I guess, explore them. Um, need to take it. Need to take some tea. Oh, so let's start with the register map here. Yeah, who am I and who am I for the other one in the same place? That's fine. And then let's look at out X to out Z. No, did I have out ABC? So the DSH does not even have out ABC. DSH to DSH does not have out ABC. That's number one. And then let's look at the control registers, I guess. Control registers. Control register 4 is on 20, register 1 is on 21, register 2 is on 22, and then all the way to register 6 on 25. What do we see here? Control register 0. We don't even have a control register 0. We don't even have a control register 0. We only have a control register 1. I mean 1 through to 6. 1 through to 6. And even the one starts at 0 cross 21. I mean 0 cross 21, and then it goes all the way to 20, 20. So 0 cross 20 to 0 cross 25, basically. But some of them do register 1. See, register 1 is on 21, and register 1 is on 20 here. And then register 4 here is on 23, which is the control register. Um, so really, they're not the same devices. And I need to do a different driver for this. That's insane. I mean, I thought I was gonna come here and then we were gonna because I'd spent a part of the weekend I'd spent a part of the weekend debugging, and in my debug I thought, so the issue was that um, in my debugging I thought the issue was that they were the same driver, but really they're not. Let me uh, really they're not. They don't share a register map, and it'll be two. So let's look at out xy out x to z. So out x to z. So out x is 28, z is 2d. Let's look at here. Out x is 28, z is 2d. Those work. Those work. And then that's why I get the canned item. If I probably allow the ID and I do the thing I did on the other one, I should get the first one. Okay, cool. So let's try and do it like this. Let's just do some hacking. LIS2DH. Okay. Okay. So as you see here, I had included a different ID just to let it through, and basically I will do here Judy, and you'll see that I added the 3F ID. So you could say I was between. There was drift. I was drifting between code bases and basically and code bases and documentation. I basically, and the thing that made me so courageous is that I've done this driver before in bare metal. Well, yeah, in bare metal. It's I'm gonna say it's in Gaia 8 UCD. So here we have drivers. This is something I did think a year ago. So here we have drivers, and then in the LIS3 we have the driver for the LIS3 DSH. And you can see we get all the fine. So I'm going to try and trick it and see if I do this. If I do this, will it will it um, will it will it work? So let's try that after allowing the ID. So let's try and put in this code here and see if it works, because the outputs are the same really. Let me see if I set it up like this, just do a force setup. Will it work? Because the outputs are the same. So if ID is equal to this 3D DH, it should be DSH shift ID. If we're here, we should, I believe we have a register right or something. There's something somewhere here. But yeah, yeah, this. Uh, why? I think let's go in here, and if it's actually a LIS3DH, int rep. Actually, you can just go. I don't care because this is throwaway basically. I'm gonna say rep. This is write data dev. So I don't even want to use this. I'll just use the actual 0 cross 2 0, and then yeah, let's build a uint 8 underscore t config byte. So that's equal to 0 cross 6 0. Another 0 cross 0, 0 cross 0, and then this thing. Which access do I want? 0 cross 7, I think. 0 cross 7. So if I build that and then I come back and I say size of config byte, what do you think? Oh yeah, I can write one register like that and then do, 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 do. Ah, my OBS went offline for a bit there. Can't see. Right register that one, that one, that one. Okay, cool. What? Let's see, what does that return anyways? And what is the status? Status is whatever. Okay, cool. So I'll just return it like that. The status seems to be okay. I'll just return it like that. Return. Um, so somehow I broke my machine. I broke my. Hmm, somehow I broke my streaming thing. Yeah, it seems to have come back. That's fine. I will do something about it next time. Cool. Let's run this code and see if that actually works. If that works, then we have some sort of solution. Yeah, we came to code and we ended up in a data sheet. Such is my life. Let's do that. That should. Oh, that's actually insane. This is insane. This is a big change. Um, I'm moving the thing. We're not getting any data, but the so basically what is happening is it knows we're different now. There's a couple of things that have changed. No, I don't want to do that. Control 1 and 6 shared. Control 1 to 6, 22. Control 1, control. This does. First of all, this one doesn't have. The one I have, which is this one, does not have control 0. I just have control 1 all the way through to 6, control 1 all the way through to 6. And control reg 1 is 20, control reg 1 is 21. Yeah, so it's being, the setup would be wrong. Uh, when I do init on my bare metal driver. Do I? Yeah, this is just the SPI. I want to see when I do the initialize for the actual. I just write to this config. That's fine. That seems fine. Is there anything else I do? No, I just configure that. Um, I do have a read temp, but I'm not using it. I have a read access. Uh, but my read access should be, I do have a flow sensitivity. Why is it all zeros now? I wonder if our out matches out L to out XL 28 out ZH 2D. Do these match? 28 ZH 2D. Yeah, these match. I never use a FIFO, so that shouldn't be a problem. I never use the FIFO, so that should not be a problem. Is there a functional description somewhere? Just a moment. I just want to see. I use a sensitivity, but I don't see where do I use the sensitivity? I see. I use it here whenever I read out. Whenever I read out a thing. So, anyways, the IDs are different. The IDs are different. The register maps are sufficiently different because uh, setting up control. The reason I keep jumping back to the register maps is because I need to find out whether is it worth it building the driver of this? Is it worth building the driver of this LIS3DH into the LIS3DH? Because if they are compatible enough, then we can kind of work out a few things. Um, let's look at the control registers. I think that's where the thing is. So the control register 4, let's look at control register 4 in the other one. So let's find the register map again. Let's find the register map again. So control register, that one starts with control register 420. Control register 4, here's 23. Control register 1, 21. Control register 1, 20. Control register 2, 22. Control register 2, 21. So the control registers are completely different. Even though, and they don't have rate 0. So that kind of messes with stuff. And then do they have a temp config register? They don't even have that. It's a bit different. That's the filter coefficient. So can you do DSP stuff already on this thing? Yes, yes. Yeah, this is the register description. So I just want to know what I would like to know. Yes, 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 yes. I like that. Wow. You can do a lot of pre-processing. You can tell the accelerometer to tell you when you've hit certain peaks. You, it looks like you can also hunt over some filter coefficients. So whenever I just did this, I just did it. GitHub. So uh, whenever you have an array of input, which this kind of devolves into a signal processing talk. Whenever you have an array of input, um, you can why is that fading? So whenever you have an array of inputs, you can let's look at something in the cultural closure. Whenever you have there's something called vector multiplication, which is where you have an array, okay? Like say this one. This is a good one to 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 kind of explain. So you have vectors like this. You will have let's say we have an array that contains three items. An array that contains three items, and let's name these items R, G, and B. Okay, so we have an array that contains RGB, and R is red, G is green, and B is blue. So those are the three primary colors, and that's how you mix up all the way colors all the way up to making the complex colors you want. So if you have an array of colors and you want to adjust it, you want the yellow to become more yellow, the green to become more green, or the red to become more green, you can multiply it by a list of coefficients. And this is just vector multiplication from matrices in high school. But basically what that means is if our sensor has vector coefficients, that probably means we can ask our sensor to do some preparatory uh, signal processing work, I guess you could say. Did I just did I seriously disclose the document I was looking at? LSDSH, LS3, LS3DH here. Okay, cool. So I want to find out about vector. Yeah, it has a filter. You can make the thing filter it. I see. So in each filter coefficient, I don't know how you use them yet, but we can tell this you can tell this accelerometer to do more stuff. So do you have vector filters? Okay. And do you have ADC? Okay. And do you have a you don't have an ADC. Do you have a peak? You don't have a peak measurement. SM2. You know what? I need to know why this thing is built. ST ST LIS3DHTR. LIS3DHTR. Saddest thing ever. Okay, cool. So the register maps are sufficiently different, and it appears as though, even though it's obsolete, the accelerometer I have has more features. And these more features could be better or they could be worse because they could make the signal, I could offload some signal processing into the hardware or I could handle it myself. So, yeah, I don't think it would be prudent to go in and modify the existing driver to cover an obsolete driver, an obsolete hardware item. Although I can just make the driver for that one and push it up, that's not a problem. And it will be just for that one. And then basically I could have my data by making the driver by myself. I need to go and report this. Alright, awesome. So I just did a small debugging session on this. The intention was to fix whatever issues I found and fold them, fold the functionality of the LIS3DH driver into this one. However, upon further examination of my dev dev kit card schematic, I found that my dev kit is equipped with excuse me, with the list which appears be the earlier version of the LIS3DH. While while they do indeed, while at first while at first glance they seem to share a register map. Upon further observation, they don't. They actually have a sufficiently different register and feature set that I think mandate a different driver. Thank you so much for the patience and the time on this. I hope I hope I didn't pull you away from too much. PS, I still think the current driver has a drift between the code and the binding. We might circle back to this if I acquire at least 2DH device. Okay, so it appears I have discovered that I need to build a new driver for my obsolete accelerometer that is on my development kit. Because whereas I thought it would be the LIS3DH, it appears I have the LIS3DH, and that is sufficiently different that I think we should, rather than actually fixing the existing driver and basically shoehorning the features into it, I think it makes much more sense to just build out a fresh, clean driver for that one. Yeah, I really intended for today's session to be a much longer one because I intended for us to break down the code and start actually working on it. However, I'm gonna have to sit back and redesign this based on the new features because my head was in the other one. And whereas I have already made a working driver for this, I've made a very basic working driver, and there's a few features functionalities that I need to find out about and how to use them, and especially for DSP, that are going to be very helpful. That it doesn't help me just jumping in and writing code. In any case, thank you so much for hanging out with me today. It's been amazing debugging with you guys and finding out what I need to do. And anyway, to show how actual software is developed, this is how it is. You spend a lot of the time discovering and a lot of the time talking to your teammates and seeing if you can help everyone and try and get help yourself. Thank you so much. I might do another stream this week on some topic, but we'll see. Let me see. I'll let you know. But thank you for coming. Thank you for sharing. And cheers. Thank you so much. That was an amazing hack session. Yeah, for sure. So let's close that. Um, Thank you so much for coming today. Cheers. See you again.